Hi guys. This is going to be the McGraw-Hill version of Lesson 7.1 like I did on Edge Elastic yesterday, only today I'm doing it on McGraw-Hill. We'll use their examples. I'm going to try to play this video. It's kind of cool, and I hope you can hear it.
When starting a new business, it's important to analyze
Curious to see how that went. All right, so this is from Reveal. I'm sure it looks familiar to you. Yesterday we talked about some vocabulary terms. So here we have the same vocabulary terms. System of equations is a set of two or more equations with the same variables. A system is said to be consistent if there's at least one ordered pair that satisfies both equations. And it is inconsistent if there is no pair that satisfies both. Okay. All right. Hopefully some of this sounds familiar to you. Okay, so here in full McGraw-Hill glory, their stuff always looks so good and inviting. I probably shouldn't say that on video, huh? Now they'll have evidence I said it. This basically gives you the vocabulary that we talked about yesterday. System of equations is two or more equations with the same variables. They're consistent if there is at least one pair that satisfies both. They are inconsistent if there's no pair that satisfies both. Now, of the consistent ones, where they do have a solution in common, they can either have one solution, which makes them independent, or they can be completely dependent and be the exact same line, okay, and have infinite solutions. So they've got this little thing down here. Exactly one solution is consistent and independent. Infinitely many solutions is consistent and dependent. And no solution is inconsistent. Then if you flip this little thing, it gives you the descriptions. And then if we flip it again, it gives us graphs. And I like the graphs. One solution. The one point where these two lines intersect is the one solution. This is a graph where both lines are the same line. You can't really see it because one line's lying on top of the other. But this is an example of infinite solutions. And then over here, the two lines are parallel, so they have no solutions. They will never intersect. Okay. All right. Consistent systems have at least one point that solves them both. So this shows you that these two lines are represented by these equations, and they intersect at one point. So our choice is consistent and independent, or inconsistent. Because there is at least one point that solves them, and only one point, that makes them consistent and independent. Next resource. Still loads slow, doesn't it? Okay, I'll just move my face around. Here we go. Okay, I'm over here. This is the example I did on Edge Elastic yesterday. This is where I got it. This is an example where you have a system of equations that have no solutions. The lines are parallel to each other, and you'll notice they have the exact same slope. So this is called inconsistent because there's just not an answer to it. There's not a solution. So it's just, declared inconsistent. Okay. Now, this one was an example where they want you to look at the two equations and decide if it's going to have one solution, no solutions, or infinitely many solutions. Now, notice the slopes on these. They're trying to trick kids. These are not the same slope, okay? These do not have the same slope, and they don't have the same y-intercept. And if you graph them in, like, say, Desmos, they're going to intersect at one point. So this is going to be one solution. Now, these ones, looking at the slopes, if the slopes are the same and the y-intercepts are not, they are parallel and they will never meet. So they have no solution. The only other thing that could happen is you could have the slopes be the same and the y-intercepts be the same. If that's the case, they're the same line, and they would have infinite solutions. Right. So here we have examples where these are not necessarily in slope-intercept form. Well, this one is down here, but these aren't. And so until we have them in slope-intercept form, we really can't tell if they're going, what kind of a system we have. So I want to hop over here to this, and I'm going to, you remember how much trouble I had writing in that edge elastic thing yesterday? Well, I'm hoping that this goes better because this is active Inspire and I'm more used to this. I need these in slope-intercept form. So I want the y on the left, and I need to get rid of the 5x. So I'll subtract 5x from both sides. That gives me negative 2y is equal to negative 5x plus 6. Then I divide everything by negative 2, negative 2, negative 2, and I get y is equal to positive 5/2 because negative over a negative is a positive, x, and then that would be minus 3 because positive 6 divided by negative 2. In this example, I want to add 10x to both sides, trying to get y on the left. That gives me 4y is equal to 10x minus 12. Divide everything by 4. And I get y equals, that'll reduce to 5/2, x minus 3. Uh-oh, those are identical. So this will have infinitely many solutions. One of those sideways 8s, infinite solutions. So the first one has infinite solutions, but let's look at the second one. Okay, so yeah, my face is over it. It's all right. We need to solve for this 6y minus 4x equals 9 and see if it's the same as this top one that's already in slope-intercept form. So we need to add 4x to both sides. Add 4x to both sides. That gives us 6y is equal to 4x plus 9. We divide everything by 6. And we get y is equal to, well, that reduces to 2/3 x. And 9 over 6 reduces to 3/2 or 1.5. But even though these two have the same slope, they have the same slope, and they have different y-intercepts. So what's that going to look like? These two lines are going to be parallel, okay? So these have no solution. So help me remember that. Okay, this one, the first one was infinite, and the second one was no solutions. So now let's go back to McGraw-Hill. Got to remember, infinite, no solutions. Infinite, no solutions. Okay, so we're back here. The first one is infinite, and the second one was no solution. Oh, I did it. Okay. Next, I have amazingly fast internet, and look how slow this is still taking to load. Okay, so here we have a check, okay? There are, I believe, 5 questions in this check, and I have assigned it to you on McGraw-Hill, okay? And so this will be your assignment for today. Like I said, it's only 5 questions, and it covers the first half of section 7.1. We'll do the second half of section 7.1 on Thursday and Friday. Okay? So you guys have a good time with that. It's only 5 questions. It shouldn't take you a really long time, and I will see you tomorrow. Bye.